course, we will discuss rational exponents and square roots that are also part of the exponent family, the exponent topic in algebra. And again, you want to review, either refresh your knowledge or see if you remember things, or review the topic from the Algebra and Trigonometry book under Radicals and Rational Exponents. And the book focuses on square roots in the beginning, but I will discuss the general rules for any kind of root. So the product rule, I also wanted to mention that this is not in our formula packet. So our formula packet does not have roots other than the rational exponents and how to solve equations with radicals, but you will need to know these rules. So the product rule says that if you have the nth root of x times the nth root of y, so the index of the root is the important thing, and you multiply them together, you can just combine them under one root and just multiply x times y. And the quotient rule says that if you have the nth root of x divided by the nth root of y, you can combine them in one root and it will have the quotient of those two expressions. And of course, the book starts with just square roots. The square root of x times the square root of y will be the square root of x times y. And the quotient rule also is just with square roots, but it can be generalized with any root. The principal square root says that if you have the square root of a number squared, the answer is not x. The answer will be the absolute of x. And the reason is that the square root of 3 squared is the square root of 9, and that is 3. But the square root of negative 3 squared is the square root of 9. And the square root of 9, we have agreed for it to be positive 3. So the principal square root is the positive quantity that when squared gives you the number under the radicand, which has to be positive. So to simplify, the square root of 16 has to be positive 4. The square root of 81 is the square root of 9, which has to be 3. The square root of 300, according to the product rule, will be the square root of 3 times 100. 100 is a square, so it's going to be square root of 100, which is 10 times the square root of 3, also written as 10 square root of 3. Quotient rule, the square root of 5 over 36 will be the square root of 5 over the square root of 36. And the square root of 5 is an irrational number, but the square root of 36 is a rational number 6. The nth root of the nth power has two possible answers. One is if n is an odd power and an odd index, then it is x itself. But if n is even, then it has to be the absolute of x, because x to the n will be positive, and an even root of a positive number is a positive quantity, but x could be negative when raised to the nth power. So a rational exponent, and again, that is in our formula packet, says that if I have a base to the m divided by n, then the denominator is the index of the root, and the numerator is either the power of m itself or the power of the root. So it's the same thing. So x to the m divided by n will be the nth root of x to the m, and the m can either go as an exponent of x, or if I'm doing calculations, sometimes it's easier to calculate the nth root of x and then raise that to a power. The principal nth root, written as the nth root of a, is a number x with the same sign as a, such that x to the n is a. And that basically says that if it is an even root, for the even root to exist, for an even indexed root to exist, the radicand a must be positive. Therefore, the nth root of a has to be a positive quantity. How do we simplify? If we have square roots, we are trying to find factors that can be squares. So 162 is 2 times 81, and 81 is a perfect square. A to the fifth is, with the product property, a to the fourth times a. A to the fourth is a perfect square because it can be written as a squared times a squared. B to the fourth is a perfect square, and I'm going to leave it like that. Another thing that you can think of is that according to the rational exponent rule, when I have the expression x to the m under a root, then that as a rational exponent will be x to the m divided by the index of the root. And since the index of a square root is 2, if the exponent under the root is even, then I will be able to divide that and create a rational expression. But if it is odd, like a to the fifth, I cannot do that. So what I'm trying to do is write a to the fifth as an even exponent times a power of a that is an odd exponent. So, which is 1, obviously. So the square root of 81 is 9. The square root of a to the fourth is a to the 4 divided by 2, so a squared. The square root of b to the fourth is b to the 4 divided by 2, which is b squared, and everything else I was not able to simplify. So under the root, I will have 2a. My answer here will be 9, a squared, b squared, times the square root of 2a. For this expression, I'm going to put everything under the root, so I'm going to have 234, x to the 11th y in the numerator, in the denominator 26, x to the 7th y. I will simplify the y's. I will simplify 7x's from both numerator and denominator. And then I'm gonna go in my calculator to simplify 234 divided by 26. Which is 9. So this is equal to the square root of 9 over 1, x to the 4th over 1, so no denominator. The square root of 9 is 3, and the square root of x to the 4th is x squared. The nth root of a to the nb, assuming that the numbers are positive and I don't have to worry about the signs, will be a to the n divided by n, which is 1, and times the nth root of b. The third root of 750, I'm looking for cubes here. 5 cubed is 125, so I'm going to try to see if 750 is a multiple of 125. 750 divided by 125 is 6, so 125 times 6. The third root of 125 is 5, and I was not able to simplify the cube root of 6. Here I have a 3, which is a rational number. Then I have fourth root in the numerator and the denominator. Therefore, I can combine them. 80 divided by 5. 80 divided by 5 is 16. The fourth root of 16 is 2, because 2 to the 4th is 16. And 3 times 2 is 6. Here, the index of the root is 4, so I'm looking for exponents that can be divisible by 4. 11 is not divisible by 4, but I can write it as a to the 8th. That is divisible by 4 times a to the 3. The b to the 12 is an exponent divisible by 4. C to the 9th, 9 is not divisible by 4. I can write it as c to the 8th times c to the 1. And d to the 20 has an exponent divisible by 4. Therefore, I can find the fourth root of a to the 8th, the fourth root of b to the 12th, the fourth root of c to the 8th, and the fourth root of d to the 20. These will come out of the root. So I will end up with a to the 8 divided by 4, which is 2, times b to the 12 divided by 4, which is 3, times c to the 8 divided by 4, which is 2, times d to the 20 divided by 4, which is 5. And what I was not able to simplify is the fourth root of a cubed c. Here is some practice for writing rational exponents. Write as a radical and simplify. Remember, the denominator becomes the index of the root, and then I have 343. Since I'm trying to find this quantity, I'm going to raise the answer to the second power instead of raising 343 to the second power and then finding the cube root. So the cube root of 343 exists. It is a rational number. So cube root of 343 is 7, and that is 7 squared. 7 squared will be 49. Of course, since we are allowed to use calculators and our scientific calculator will have the ability to have rational exponents, I could have done 343 to the 2/3, and my calculator would have given me the answer of 49. 9 to the 5/2 is the square root of 9 raised to the 5th power. That is 3 raised to the 5th power, and that is 81 times 3, 243. And again, I can check with my calculator. Use rules of exponents and rational exponents to simplify. I'm going to multiply the coefficients, 5 times 2 times 3, that's 30. And then I'm going to multiply the bases, x to the 3/4 times x to the 1/5. It will be a sum of exponents. So I'm going to go in my calculator, and I'm going to do 3/4 plus 1/5. If I had a scientific calculator, I could use the function button, the fraction button, so that I could have my answer as a fraction 19/20. So the answer is 30 times x to the 19/20 power. And for the test, do not write this as a root, the 20th root of x to 19, just leave it with the rational exponent. When you have a fraction that is raised to a negative power, then that will be the fraction in the denominator. A fraction in the denominator is the reciprocal of the fraction. So actually 16/9 to the negative 1/2 is 9/16 to the positive 1/2. I just wrote the reciprocal fraction. The exponent 1/2 is a square root, 9/16, and the square root of 9 is 3, and the square root of 16 is 4. So my answer here will be 3/4. And again, if I were in my calculator, make sure you use parentheses, and I wrote 16 divided by 9 and raise that to the negative 0.2. I mean, negative 1/2. I will need a parenthesis, but I can just write 0.5. It will be 0.75, and 0.75 as a fraction is 3/4. The other thing that we want to know how to do with radicals is adding radicals. When you add radicals, they have to be like radicals, like adding like terms. So you cannot add the square root of 12 with the square root of 3, but you could add the square root of 12 with the square root of 12, or the square root of 3 with the square root of 3. So we do want to simplify here. 12 is 4 times 3. And the square root of 4 is 2. So 5 times 2 will be 10. So I have 10 square root of 3 plus 2 square root of 3. And that will be 12 square root of 3. For the next one, 80 is 16 times 5. Remember, there is an x there, so it's 80x. So that will be 16 times 5x. And that has a coefficient of 3. Minus 4, the 45 is 9 times 5. And remember the x there. So 45x is 9 times 5x. In the radicand, in the root, 3 times the square root of 16 is 3 times 4. So 12 square root of 5x minus 4 times the square root of 9, which is 4 times 3. That's another 12 square root of 5x. And 12 square root of 5x minus 12 square root of 5x will be 0. When I have cube roots, I need cubes instead of squares as factors. So 9,000 is 9 times 1,000. The cube root of 1,000 is 10 because 10 cubed is 1,000. So that will be 6 times 10, 60. Cube root of 9. And if I want to be able to add it with 576, I am hoping that 9 is a factor of 576. So if I divide by 9, I will get 64. And 64 is actually a cube because 4 to the third is 64. So I have 7 times the cube root of 64 is 7 times 4, 28. Cube root of 9. And that will be 88 cube root of 9. The last part of dealing with radicals is to rationalize denominators. Rationalize denominators means to have a rational number in the denominator. And we did see a fraction earlier. That was the square root of 5 divided by 6 over here. That had a rational denominator, so we are happy with this answer. What we don't want is to have the square root of 5 in the denominator. If we have a square root in the denominator that we cannot simplify, then to rationalize the denominator, we will multiply both denominator and numerator by the square root, the irrational part. The b is rational, so we don't really care for the b over there. We just want the square root of c to go away. If we multiply with the square root of c, the denominator will be b times c, because square root of c squared will be c. The numerator will be the numerator that we had times the square root of c. If it is an nth root of c to the m and you can simplify it, then what you want to do is you want to multiply by whatever exponent of c you need to get c to the n as an answer. So that will be the difference between n and m. Whatever that number is, you need the remaining factors to have the nth root of c to the n in the bottom. And you will multiply numerator and denominator by this quantity. And in the denominator, you will have b times c. And in the numerator, you will just have your numerator times whatever nth root of c you multiplied by, you needed. If you have a binomial in the denominator that either has square roots or has imaginary numbers, you want to use the difference of squares formula. The difference of squares formula says that if I have two conjugate expressions, and conjugate expressions are binomials that have one of their terms with identical sign and the other term with the sign switched, one is positive and one is negative, then this will equal to a squared minus b squared. And when you square square roots, you get rational numbers. And when you square imaginary numbers, you also get rational numbers. So the trick here is to multiply by the conjugate of the denominator. The conjugate of this denominator, a plus b square root of c, is a minus b square root of c. And if you multiply the denominator by that, you need to multiply the numerator by that so that you don't alter the fraction. You just alter the looks of the fraction, but not the value of the fraction. So in the numerator, you're gonna distribute. And in the denominator, you want to apply the difference of squares or distribute. To get the difference of squares, it will be a squared minus b square root of c times b square root of c. That will be b times b and square root of c times square root of c. So the expression in the denominator will be a rational number. So let's practice this with our two examples. To rationalize this denominator, the only irrational part of the denominator is the square root of 10. So I'm only going to multiply by the square root of 10 in the denominator and in the numerator. I will get 2 square root of 3 times 10 is 30. Remember the product property of roots of radicals. You can multiply those. In the denominator, I have 3 times 10, which is 30. And you don't want to be done here because the problem will ask you to simplify completely. And you can simplify now the rational parts. The 2 and the 30 simplify to 1 and 15. So your final answer is square root of 30 divided by 15. For the next one, I want to multiply by the conjugate of the denominator. The conjugate of the denominator is 1 minus the square root of 5. 1 minus the square root of 5. So this will be 4 times 1 minus the square root of 5. In the denominator, it will be 1 squared minus square root of 5 squared. So I have 4 in the numerator if I distribute minus 4 square root of 5. In the denominator, I have negative 4. You can simplify that. You can simplify the 4 in the top with the negative 4 in the bottom. So the way to do that, when you have a denominator that divides a polynomial in the top, that denominator has to divide every term of the polynomial in the top. So you're going to have 4 over negative 4, and then you're going to have minus 4 over 4 square root of 5 over negative 4. So 4 over negative 4 is negative 1, and 4 square root of 5 over negative 4 is negative 1 square root of 5, but it has a minus in front, so that will be plus 1 square root of 5. And this is a review of radical and rational exponents.